Okay, number one. A particle moving along the x-axis is given, the velocity is given by that function. What is the acceleration? So what do I have to do to find the acceleration? Take the derivative. So v of t equals 3 plus 4.1 cosine of 0.9t. This was on a test in the past, and like way back when we first started talking about derivatives, and you didn't know how to take the derivative of this function analytically. You only knew how to take the derivative with the calculator. But now you do know how to take the derivative analytically. So a of t is what? Well, okay, 0, thank you. 4.1 times negative sine of 0.9t times 0.9. So chain rule, trig rules. We could simplify this a little bit to say negative, what is that, 3.6, 4.5? Am I right? No? Oh, that's 0.9. Okay, I'm sorry. Then what is it? 3.69? Sine of 0.9t. And then we're looking for the acceleration at t equals 4. So we just plug in 4. What'd you get? 1.6 what? There's always 3 decimals. 633? Okay. All right. Are we good? Okay. That should be easy. Number 2, I know your brain, you're starting to try and look for shortcuts. Don't overassume things. But if I'm looking for the integral from -1 to 3 of 35 dx, what am I asking you to do, essentially? I'm telling you to find the area, and then you have to determine whether the area is going to be a negative or a positive value, right? So we're going from -1 to 3 of the function 35. So negative 1 to 3. So let's say this is -1. That's 3. So what kind of shape are we getting? A rectangle. What's the width of the rectangle? Okay, and I'm going to show this because later on it will matter. The width of the rectangle is going to be 3 minus -1. That's going to be important later on when we get deeper into this, to see it this way. And then what's the height? So we can say the length is 35. So the area is, so length times width, so 4 times 35, which is 140. So now we look at the signs of the integral. Is it going to be a positive or a negative value? Positive, because this whole thing is what? Above the x-axis. Okay, so that's that. We have kind of broken down what an integral is in terms of the graphical approach. Kind of what it means. It means area under the curve, including signs. We're going to get really in depth with applications of integrals as time goes on. If you notice, this unit is pretty long, right? It's like 20 lessons or something like that. It's long. But before we do that, the next step is to know how to use your calculator to find an integral, which means we're going to evaluate integrals using really crazy equations. Some of you already know how to use your calculator to find the integral. Yeah? You can't figure it out? Okay. Some of you have cheated your way through life using your calculator. Okay. Real fast though, do you remember how to use your calculator to find the derivative? Okay. How do you use your calculator to find the derivative of a function? Okay, you can hit F3. Is it F3? Yeah. And then differentiate, okay. Yeah, same thing, okay. And then yep, plug in the function, then comma x, close parentheses. Now remember what I've told you in the past, the AP exam and therefore this class, you shouldn't be using your calculator to determine the derivative function. You should only be using your calculator to determine the derivative at a point, right? So your calculator has the ability, you say, the derivative of the function, comma x, close parenthesis, and then you hit enter, and it gives you the function. But that should never be what it's used for. You should always put evaluate when x equals blah, blah, blah. Okay? I mean, you could use it to check to see if you're right, but it's not going to be beneficial. Okay? So first thing I want you to do is determine the numeric derivative analytically, so do it yourself, and then use your calculator to verify your answer for these guys. Just a review, it's a good review, to make sure you're still remembering. So do it analytically, and then use your calculator to check to see if you're right. All right. So what is the derivative of the first guy? What's the function derivative? 3x squared minus 4, and then we're going to evaluate when x equals 2. So 3 times 2 squared minus 4 is 8. Okay? And then number 2, what's the derivative of that? Secant squared x plus 4. Good. And then we're going to plug in when x equals pi. So secant squared of pi plus 4. What's secant of pi? What's cosine of pi? Cosine of pi is -1. So the reciprocal of that is -1. So -1 squared plus 4, so 5. And then number 3, we're going to have to use what? Product rule. So the derivative of the first is 1 times the second thing, sine of x, plus cosine of x, so the derivative of sine, and then times x. Cosine of just x, so it's not x squared. Now we're going to plug in 0, so sine of 0 plus cosine of 0, and then times 0. What's sine of 0? 0. Cosine of 0 is 1. I know it's a simple problem, but I want to make sure you know your trig, so 0. Okay? And you checked your work with your calculator, yeah? No, you didn't. You all did it. You did check your work with the calculator because you didn't do any work. You just used your calculator, didn't you? Okay. So just to refresh your F3 option 1, type the function in, then comma x, close the parentheses, and then you hit the evaluate button, and then x equals whatever. Or, what's the other thing? What'd you say? Second and 8? So for those that are listening at home, this is for the TI-89. Oh boy. You like that? Okay. So let's do integrals with the calculator. Okay. But wait a minute, let's take a step back, because I wouldn't want to make it too easy for you. I want you to determine, I would never make anything easy. All right. I want you to determine this integral graphically, like what we've been working on, and then we'll get into using your calculator. So graphically, what is this? Semicircle. Okay. So it's a semicircle with a radius of 7, so -7 and 7 there. And we are looking for the integral from -7 to 7, so we're looking for the area of the whole semicircle this time, right? So the integral from -7 to 7 is 49 minus x squared dx is equal to what? Give me the formula. 1/2 pi r squared, and the radius here is 7. So again, it's the area of the half circle. The area of the circle is pi r squared. We've got to divide it by 2. So what is that? 24.5 pi-ish? That's right. Okay. Now we're going to do it with your calculator. Right? Remember I told you yesterday also, what would make this semicircle below? So if I said the integral from -7 to 7 of negative rad 49 minus x squared dx, then we are finding the area under the curve, or the area bounded by the x-axis and the curve, but because it's below the x-axis, it is negative. So it's the same answer, it's negative. But my point is that this equation is the equation for the bottom half of the semicircle, right? Just like if I said f of x equals rad x, what does that function look like? Uh-oh. It's the half of the parabola, right? It's not the whole parabola, because if we said the whole parabola, it's not a function, right? So this is the upper half of the parabola, whereas if I throw the negative out front, that's telling me to focus on the negative version of the square root, right? Because the square root of 25 is what? Or negative 5. This negative just tells us to look at the negative part. So down there. Anyways, that's beside the point. Anybody know how to use your calculator to find the integral? Okay. All right. So if you're going to use find it the same way you did the derivative, it's F3, and then what is it? Option 2 says what though? Integrate. So F2, integrate. Then a parenthesis opens up, right? You type in the function, or the integrand. So in this case, the rad 49 minus x squared. Make sure the 49 minus x squared is in its own parentheses. Okay. Then what? I'll put this up here, but then you're going to put comma x. So you're integrating in respect to x. That's by putting x, you're saying basically dx. Now it's a little different than the derivative. At this point with the derivative, you would close a parenthesis and say evaluate or evaluate. In this case, you're going to put comma, lower bound, comma, upper bound, and then close your parenthesis. The value of the lower bound. And then close it, yeah.
Comma, lower bound, comma, upper bound?
Yes. Okay, so F3 option 2, or Abigail said second, what, 7? Second 7, that's the blue button, and you see the little S above the 7, yeah? Okay, so second 7 works too. And then type the function in, comma x, and then comma lower bound, so in this case negative 7, comma upper bound, in this case 7. And then close the parentheses, and you've got it. Okay? Make sure you got it, make sure you have the same answer. So use your calculator to evaluate these. Okay? And I'm going to assign this, okay? I want you two to do the top 3, you two to do the bottom 3. Do you know how to take the integral of this function? Do you know how to take the integral of that? No. The only functions you know how to take the the integral of right now are what? Lines, because that makes what kind of shapes? Triangles or trapezoids. Constant lines, which makes rectangles, and then the semicircles. So these you don't know how to do yet, so don't freak out about it. You'll learn. Actually, I should say you'll learn some of them. You guys can take the derivative of every known function to man. You will not know how to take the integral of every function, unfortunately. Okay. So, all right, we've talked about this in the past. Sometimes your calculator reads like that. Oh, especially this program, this function. Since it says x sine of x, it's reading that as a weird word. It's reading, it's not reading it as a function. So put a multiplication sign in between x and sine. What do we say? Number 1 is, oh, I don't have it there. Number 1, what do you got? 2.043? Okay. Number 2? 3.142? Okay. And number 3? 6? Okay. So check your work. Just to take a step back on number 1, you need to type in the integral and then parentheses and then x times sine of x. You have to make sure that multiplication sign is there. Does this, when you type in sine, it opens up a parenthesis, right? Okay. So parenthesis x, you got to close that one, and then comma x, comma, what is it? Negative 1 to 2? Because again, it's reading it as a word, x, S-I-N-X. All right. The second batch. Number 1. 5.999? 919, thank you. Number 2? 4.712. And then number 3? 5.969? 964. So this is times what? What was it? 10 to the 91? Why is number 3, the first number 3, like a small, finite, less than 1 number, and then number 3 is getting really, really big? Yeah, but what does it look like graphically? Because remember, we're trying to find areas, right? What does the graph of e to the negative x squared look like? It's e to the what power, always? In number 3, no matter what I plug into x, we're going to say e to what power? A negative number, right? Because you're squaring the x and then you're taking the negative of it. So when you have a negative exponent, what happens to the value? You flip it over, so it's 1 over e to the positive exponent, which as x gets bigger and bigger, the whole value gets smaller and smaller, right? So this, what does that function look like? Graph it with your calculator real fast. I want you to graph both number 3's in your calculator. Put one in y1 and one in y2. I don't know. All right. So thinking about max and mins, what is the highest value that number 3, the first number 3 can obtain? 1. If you look at the graph, it's 1. Because as x gets bigger and bigger and bigger, what does the value get closer to? 0. So as x gets infinitely negative, it'll still approach 0. So where is the maximum occurring on this? At 0. And what would that be? E to the 0 is 1. So you see something like this from 0 to 5 for the first graph. I think it's... Is it concave up or down? What does it look like? So is it kind of like this? Something like that? That's for this one. Whereas for number 3, at 0 it's still 1, but it's going way up like that, right? And at 6 it's really, because you plug in 6, you get a really big number, right? So the area under this region is going to be huge, where the area under this is going to be relatively small. You guys okay with that? That brings up the other point. We were talking about max and mins. This is a good review. I like this. How would I find, show me, or how would I find analytically the maximum value of the first number 3? So let's do that. Not the integral part, but just the integrand part. So if I said f of x equals e to the negative x squared, I want to find the absolute max. Okay, so take the derivative. What is the derivative? E to the negative x squared times negative 2x. Okay, then what do? I've got to find, what are they called? Critical points. The zeros are critical points, but what other kind of critical points are there? At endpoints, which there aren't, because I didn't give you a domain. Or what? Where the derivative does not exist. Can I plug in any x value and get any answer out? Get an answer out? Yeah, so it exists everywhere. We're going to set this equal to 0. So when does this equal 0? When x equals 0 because of this. Does this ever equal 0? No. So when x equals 0, you have a critical point. Then you check your number line on f prime. The derivative is 0 here. What do I do to find the signs over here? Plug in a negative. If I plug in a negative here, what do I get? Always positive. If I plug in a negative here, what do I get? Okay, let's plug in a positive over here. What do I get here? Positive and negative. So since f prime is positive for all values from negative infinity to 0, and negative for all values from 0 to infinity, what can we say about when x equals 0? No, it's not relative. It's absolute max when x equals 0, since we would say f prime of x is less than or equal to 0 for all, greater than or equal to 0 for all x within negative infinity to 0, and f prime is less than or equal to 0 for all x within 0 to infinity. That's a good review. You guys okay with that? You remember it?
I said yeah.
No, you didn't. You said no.
No, I said yeah.
Okay. Fair enough. Oh, I did want to spend a minute on this. There's the function f of x equals 3x squared. I want you to evaluate these things, and we're trying to explore some of the rules that we're going to talk about on Tuesday. Okay? So I want you to evaluate each one of those parts. And then when you're done with that, I want you to answer these questions. See if you can find something. All right. Let's see. If you're using your y list, you would say y1 equals 3x squared. And then in the home screen, you would say the integral, parentheses, y1, parentheses x, like that, comma x, comma, in this case, 0, comma 5. Okay. What did you get for part A? 125. B was negative 125. Okay, C, 8, and D. Okay, so seriously, I want you to answer those questions and come up with what you're looking for is maybe an equation that relates those two somehow, and an explanation of why they're doing what they're doing. Okay, the integral from a to b of f of x dx, this one was, I think, easy. And the integral from b to a of f of x dx. What do we notice about these two functions? How are they related? The lower bound and the upper bound are switched. Well, which examples show that? A and B. So A is the integral from 0 to 5. B is the integral from 5 to 0. So if the bounds are switched, what do we notice about the answers? The signs are switched, right? Okay. So in other words, and I'll let you write that out. So if the limits are switched, then the sign of the answer is changed as well. So if I were to say, what is the integral, and we're going to write these out in the future, but if I say, what's the integral from 5 to negative 1 of some function? Actually, let's do one here. If I say of 4 dx. What is wrong with this, or how is it different than what type of problems we've done in the past? What's the lower bound here? The lower bound is the bigger number. And that doesn't make sense, right? So we can use this rule that we just talked about. If I flip the bounds and say negative 1 to 5 of 4 dx, then what happens? Just put a negative out front. Right? Because the sign changes. That's all. So what kind of function is this? It's a line. So what kind of shape are we getting when we're finding the area? Rectangle. What's the width of the rectangle? 6, because it's that distance. And what's the height? 4. So then this would be negative 6 times 4. So negative 24. You guys get that? Yeah. Okay. Another way to look at it is to say, okay, I'm going from negative 1 to 5, and I'm looking at the function 4. Actually, I'm not going from negative 1 to 5. I'm going from what to what? I'm going from 5 to negative 1. So if I'm going from here to here, I'm going what? Backwards. So what is my width, in a sense? It's negative 6. Now, the width is 6, but it's in the negative direction, right? And what is the height? A positive 4, because it's above. And so we just say negative 6 times 4 is negative 24. So that's how you can view it graphically, that I start here and I go here, so which direction did I go, and associate that sign. But analytically, you should be thinking, this is in the wrong order, so I'm going to flip it, and I'm going to make a negative out front. Does that make sense? Okay. What about number 2? what is the relationship between those two things? The integral from a to b of f of x dx and the integral from b to c of f of x dx. How are these related? No, but just looking at these two functions, how are they related? Don't even look at the numbers, just look at what's different about them, what's the same about them. The upper bound of one is the same as the lower bound of the other. So which one of those examples, A, B, C, or D, has that relationship? C and D. So let's look at that concrete example here. The integral from 0 to 2 of f of x dx is what? 8. And the integral from 2 to 5 of f of x dx is 117. We kind of talked about this one yesterday. What's the relationship between these two? If you add these up, you get A. Well, why is that? Because A is the integral from 0 to 5. Or we could say, look, the upper bound is the same as the lower bound of this guy, so this is finding the area from here to here, and this one is finding the area from there to there. So then to find the integral from the whole thing, we just add those up. As long as what? As long as there's no gaps, right? And the reason there's no gaps is because the upper bound is the same as the lower bound. So, graphically, we're going from 0 to 2 for the first function. That's 3x squared, so it's something like this. We're finding the area there. That's for part C. And then D is from 2 to 5. So that's like this, finding the area of this guy. So finding the integral from 0 to 5, you just add them up, right? So, give me a general equation for this right here. The integral from A to B plus the integral from B to C equals the integral from A to C of f of x dx. Okay? And that's going to apply on every type of integral, even when you start looking at going backwards and getting under the curve and everything else. It's a very beautiful thing. Yes. My wife looks like, you know, the letter E. E is beautiful, so is my wife, see?
Does she like it expanded to a max?
That's elegant, right? The integral symbol is elegant, right? Right, okay.